We talk about problem 25 from AMC12B. It turns out that this problem is not as difficult as it seems if you know about regular pentagon. In fact, if you want to take AMC, AIME, and other competitive math, it is really useful, or I should say, it is necessary to know about regular pentagon. So by definition, it's a polygon with 5 equal sides and angles. And there's basic property, for example, what is the side length, what is the angle, and the symmetric nature of it. And it's really important in mathematical computation. So here is a regular pentagon, and that's a circle associated with it. Sometimes you need to figure out the relation between the side and the circle radius, and the side and area of pentagon, and the special angles here, right? So we're going to cover a few. So interior angle is very easy. The total is this. You divide by n, you plug in the number, is 108. And then the half of it will be 54. This will be 54. This will be 72. This interior angle will be 72. Or you can calculate it from 360 degree divided by 5, also 72. And there is special triangle that is 72 degree isosceles triangle, and 36 degree. That is formed by the diagonals and sides. We'll cover that. And of course, the golden ratio in pentagon, that is the diagonal and side ratio, that is 1 plus square root of 5 over 2, or approximately 1.618. That's golden ratio. You can find that in pentagon. Or in a regular pentagon, if you connect the diagonal here, important property that this is parallel to the sides here. So B parallel to CD. Now similarly, if you were to connect another diagonal, so this is parallel to the other side, so that is AD will be parallel to BC. Now you have a parallelogram here. And not only that, since the sides equal to each other, it's more like a rhombus. The length here would be A and A. So let's call this point P here. P, B, C, D. Alright, PBCD is a rhombus. Let's look at the other triangle here. So the triangle ACD, in the degree here, would be 72, 72, and 36. So this is the 72 degree, and this is 36 degree. So you have this triangle, and similar to the other triangle here, ACD is similar to the triangle here, which is also 36, 72, 72. So that is similar to triangle D, and then we say P and E. Okay, so the side lengths would have the same ratio. What is the diagonal length? Let's assume AC equal AD equal X, and then because of the similar triangle, so what you get is the side length ratio, which is X over A. This is A, right? So we have X over A is going to equal to, side length here is A. This side length is, special value here is the X minus A. So equal A over X minus A. This is X minus A. If, let's say if A equal to 1, set A equal to 1, what you have is the X, the ratio would be X would equal 1 over X minus 1. This is nothing but the famous golden ratio equation. So in summary, It's good to know this parallelogram or rhombus and this special triangle and the golden ratio of the diagonal over side. Those facts are really useful in competitive math. And the question here is that a regular pentagon with a given area 1 plus square root of 5, if you print out and cut out and you try to fold each vertex into the center of the pentagon, you're going to form a new smaller pentagon. What is the area of the new pentagon? All right, so multiple choice. Here, the problem would be easy if you know all the basic facts. For this problem, it's good to know some of the basic facts about regular pentagon. This diagram, I draw out the center and the side length A and the distance from the center to the side length H. And what is the relation? Now, we don't know some of the shape of this angle. This is not regular. The interior angle here is 2 pi divided by 5. Okay, divided by 5. So that would be 72 degrees. So which means this would be 36, half of it would be 36. And this one would be 90 degrees minus 36, that is 54. So the angle OCD is going to be equal 54 degrees. What is the relation between R, H, and A? Here, H is going to be R sine 54 degrees. Now, for any regular pentagon, you would have this relation here. Now, in our problem, we try to fold each vertex to center O. So which means the folded line is going to be halfway here, right? So let's draw it out. This length is also R. And the folded line is right in the middle. This dash line is going to be folded line, which means we'll bring A to the position O. So this is going to be part of the size of the new pentagon. In order to find out the ratio of the area, it's just enough to find out the ratio of either the side length or the H or R. In this case, let's find out H here, right? The distance from the center to the new side length here is going to be half of R. The H prime, which is R divided by 2, because the folding line is right in the middle. So the ratio here of the new H and the old H is going to be the ratio of R over 2 over R sine 54 degree, and that equal to 2 sine 54 degree at the bottom, and R would cancel. This would be 1. Alright? So the problem is easy, even though it's problem 25, but the key here is, however, you have no sine 54 degree. For that, I have a YouTube short video earlier, try to figure out what is sine 18 degree. As a matter of fact, if you take competitive math, it's probably a good idea to memorize the value of sine 18 degree. So what is sine 18 degree? Sine 18 degree is square root of 5 minus 1 over 4. And from there, you can derive. You don't have to memorize sine 54 degree, but what you can do is know that sine 3x equal 3 sine x minus 4 sine to the third power of x, right? You can just plug in, and here I skip the steps. It's going to be square root of 1 plus 1 over 4, all right? So the area here, we're given that the old area, let's say the delta, equal square root of plus 1, and we try to find out what is the smaller area. Of course, we know that the area ratio is the square of the size ratio, f prime over h, in this case. So that would be 4 sine squared 54 degree. So it's going to be 1 over 4 sine squared 54 degree. Plug in the formula here. The area here is going to be delta, which is square root of 5 plus 1 over 4. And then plug in here, it's going to be square root of 1 plus 1 square. And 4 square would be 16. So 1 of it would cancel. So you cancel one term, and this square would become just one term. And then this one, you're going to cancel, becomes 4. So that's equal to 4 over square root of 5 plus 1. Of course, you multiply square root of 5 minus 1 on both top and bottom. And here happens to be 5 minus 1. That's 4. So the final answer is square root of 5 minus 1. So this problem, even though it's problem 25, if you know about the special value of sine 18 degree, which is covered in my YouTube Shorts video, then you can derive on the spot sine 54 degree if you don't memorize it. Okay, you don't have to memorize those numbers. This is the only thing you need. Right, for this and other interesting math problems, please like, share, and subscribe to the channel.